What's up guys, this is Massey. Welcome to another video. In this video I want to show you how to find out the rate of change using limits. I'm gonna solve 4 different examples. The first one is object dropped from a tower. An object is dropped from the top of the 100-meter high tower. Its height above ground after t seconds is 100 minus 4.9 t squared meters. How fast is it falling 2 seconds after it is dropped? So we need to have the limit of f of x plus h minus f of x divided by h. That's the formula for finding slope or rate of change. So this is going to be the function. So it's going to be 100 minus 4.9 t plus h squared minus 100 minus 4.9 t squared divided by h, limit when h approaches 0. This and this cancel out, and that's going to be negative 4.9 t squared plus h squared plus 2th plus 4.9 t squared divided by h, limit when h is approaching 0. These two parts cancel out, and h from the numerator and denominator cancels out. Is going to be negative 4.9h minus 4.9 times 2 is 9.8 t. And the limit when h goes to 0, this part is going to be 0, so we have negative 9.8 t. Then the slope or rate of change 2 seconds after that is going to be negative 9.8 times 2. You calculate it, it's going to be negative 19.6, and the unit is going to be meter per second. So that's the rate of change or speed of this object. Let's do the next example. It says at t seconds after liftoff, the height of the rocket is 3t squared feet. We're talking about speed of the rocket. How fast is it climbing 10 seconds after liftoff? So again, we need to find the speed. So speed, rate of change, these things are calculated using this formula. We have the function 3t squared is going to be 3t plus h squared minus 3t squared divided by h, limit when h approaches 0. Then you expand it. It's going to be 3t squared plus h squared plus 2th minus 3t squared divided by h when h approaches 0. Then these two parts cancel out. You have h squared plus 2th divided by h. It's going to be h plus 2t. When h approaches 0, it's going to be just 2t times 3. Don't forget that. I forgot to put the 3 for all of them. So it's going to be 3 times 2t is going to be 60. So it says how fast is it climbing? 10 seconds after liftoff. So I need to sub 10 here. It's going to be 6 times 10. It's going to be 60. 60 feet per second. That's going to be the speed or the rate of change. Next example. What is the rate of change of the area of a circle a equals to pi r squared with respect to the radius where the radius is r equals to 3? So again, when you use the same formula, it's going to be pi r plus h squared minus pi r squared divided by h when h approaches 0. That's going to be pi r squared plus h squared plus 2rh minus pi r squared divided by h. So then these two cancels out, and h from numerator and denominator is going to cancel out, and we have limit of pi h plus 2 pi r. And since h is approaching 0, this part is going to be 0, it's going to be just 2 pi r. So 2 pi r is going to be the rate of change function. We need to find it when r is 3. So it's going to be 2 pi 3. It's going to be 6 pi. That's the rate of change. Next example. Balls changing volume. What is the rate of change of the volume of the ball? V equals to 4 over 3 pi r cube. With respect to the radius, when the radius is r equals to 2. So we need to find rate of change again. F of x plus h minus f of x divided by h when h is approaching 0. It's going to be 4 over 3 pi r plus h cube minus 4 over 3 pi r cube divided by h when h is approaching 0. So that's going to be 4 over 3 pi r cube plus 3r squared h plus 3rh squared plus h cube minus 4 over 3 pi r cube divided by h when h is approaching 0. This part and this part cancels out, and h from the numerator and denominator cancels out, which will be limit of 4 over 3 pi 3r squared plus 3rh plus h squared when h is approaching 0. So it means that these two parts cancels out. We have 4 over 3 pi times 3r squared. When you multiply, it's going to be 4 pi r squared. That's the rate of change. When you sub r equals to 2, it's going to be 4 pi 2 squared. That's 4 pi times 4 is going to be 16 pi. This is the rate of change, or balls changing volume. So change of volume with respect to time. So the unit of r is not given here, but if we assume that it's centimeter, the rate of change of volume is going to be cubic centimeter per second. That's how we find out the unit of the rate of change. I hope you enjoyed this video. Please leave me a comment if you have any question, and I'll get back to you as soon as possible. I will leave some related videos and playlists in the description in case you need extra help and extra practice question. You can just take a look at them. Don't forget to subscribe this channel. If you subscribe it, you can have access to many other videos regarding math, chemistry, and physics. Thank you for watching and have a great day.